In this video, you will learn the basic use of graphical analysis. You will learn how to enter data, adjust data columns, and customize a graph. Additionally, you will learn how to perform curve fitting on a dataset. You will also learn how to analyze the graph using a residual plot. When you open the program, you will see a screen like this. In this case, we choose manual entry. We start by maximizing the program to fill the entire screen. We have some measurements of a spring that stretches when loaded with weights. You can see this. In the image here are the data we recorded, and we will enter them into the program. We enter the mass measurements in the X column and the extension measurements in the Y column. When we enter the data into the columns, the points will automatically be plotted in the coordinate system. Before we proceed with data analysis, we need to label the X and Y axes correctly. We click the three dots next to X, then select Column option. In the name field, we write mass, and next to it, we write the unit kilogram. We do the same for the Y-axis, where we write extension in the name field and the unit meter. You can now see that the axis labels have changed. In this case, we want both axes to start at 0. There are several ways to do this, but here we show the simplest. Click the number at the bottom of the axis and type 0. Now we are ready to perform curve fitting. We click the graph icon and select Apply Curve Fit. The program will always suggest linear regression, but in this case, we choose proportionality because we expect the extension to be proportional to the load. We click Apply. Now we see a small box showing the regression equation. We move it so it doesn't cover the graph. There's also another useful piece of information here, the so-called RMSE value. RMSE is a measure of the typical deviation between the data points and the regression line. We will return to the ERMSE value later. That was the first part of the video. You have now learned how to enter data, rename data columns, adjust the coordinate axes, and perform curve fitting. In part 2 of the video, we will focus on calculated columns and the residual plot. We start by creating a data column based on the regression equation. We click the three dots at the top of one of the existing columns and select Add Calculated Column. We name it Fit because we are fitting data with a curve. The unit should be meter. We click Insert Expression and choose Custom Expression. In the input field, we write the slope, which was 0.4223 times mass. We type m, and it will suggest mass. We can also type it manually, but we must remember that the variable name must match the one we assigned and be enclosed in quotation marks. We click Apply and see that a new column has appeared. The residuals are the difference between the measured values and the values from the fit function. We now create a new calculated column. We name it residuals. The residuals have the same unit as the e-values, which is extension measured in meters. We click Insert Expressions again and choose Custom Expression. This time, we write extension minus fit. A new column now appears containing the residuals. We want to plot the residuals as a function of mass. We do this by clicking Options in the top right corner. We select two graphs. The x-axis is correct, but we need to set the y-axis to residuals. We click the axis title, deselect extension, and check residuals. The residual plot fluctuates up and down, which is a good sign. It should ideally be unsystematic. If it is systematic, for instance, a parabolic curve, it indicates a systematic error. either in the experimental conditions or because the model is too simple or incorrect. Remember to save the file by clicking Untitled in the top left corner and choose a name and location. You should always insert the graphs you work with into your journal or report. This is done by clicking the file name again in the top left corner and selecting Export. First, under Graph Shape, change the format to 16:9, otherwise the regression label will overlap the graph. Click Save PNG, then select Graph 2 and repeat. You will be using this method repeatedly in upcoming experiments.